Alright, this is Jared Moore recording my final project for linear algebra for Dr. Palmer's class. For my final project, I created a Java program that basically calculates the probability of randomly generated matrix being inversible or having an inverse. So first I'm going to show you the source code, what I wrote to make this program work. So as I said, I wrote this in Java. This is just a Notepad++ editor showing the code I wrote. So I'm going to start down at the bottom with the actual calculation. So here is my class or method that calculates the actual determinant of a random matrix. So as you can see, the parameter passed in is any two-dimensional array, which is, I'll show you later where it's randomly generated from. Then if the length of the matrix is 1 or 2, as you know, the determinant's a lot easier to calculate. So I have, if the matrix length is 1 or 2, there's a simple result that's calculated, and then the program just returns that result from the method. Else, if the length is longer than 2, so if it's a matrix that's like a 3 by 3 or anything bigger, it's going to use recursion to actually calculate the determinant of the matrix. And if you don't know what recursion is, it's kind of hard to explain, but basically it traces back through a program backwards, and it will calculate that value the way I've set it up. So I'll show you the other methods now. I have a simple method for printing a matrix right here. Just prints the matrix out, each value, so you can see what's going on. It was the easy way for me to be able to determine if I was actually calculating the determinant value correctly. And here is my create matrix method here, where I randomly create a matrix. So right here, as you can see, each position in a two-dimensional array is randomly generated between the numbers -100 and +100. So up here, I also have a method to clear a matrix. This is basically just resetting everything to 0 so that I can easily loop through without a bunch of variables in my main method, just using the same matrix variable to create a new matrix every time without having to create a new variable. Instead, I just clear the matrix out to all zeros before I randomize it again, just to make sure there are no errors with that. Now here's my main method that actually was what you will see run in the application I'll show you in a minute. So it just starts out, it prompts the user for input, and the user can input any size n for any n by n matrix. So literally anything. You could even do size 100. It would take forever, but you could do that if you want to. Then it will prompt the user again and ask how many matrices you want to create of that size. So you could do 1,000, 10,000, whatever you want. The more you want, obviously, the slower the program will become. And then basically, based on the user input, I have a loop that loops through using those other methods I show you, creating a random matrix of that size, and then it loops that many times for whatever the amount the user inputted was. So say if somebody wanted a 4x4 matrix and wanted 1,000 times, it'll loop through this method right here 1,000 times, creating, clearing a matrix, printing out the matrix, and printing the determinant. So now I'll show you how the program actually runs. So let me make sure it compiles real quick. Alright, so no errors. Now I'll actually run the code here. So there, as you can see, it says Jared Moore, Linear Algebra Final Project 2018, Dr. Palmer. Now, then it prompts and asks, please enter the size n of your n by n matrix. So I'm going to say 4. And the amount of randomly generated matrices I'll create will be 50, just to start. So you see that works pretty quick. It calculates the determinant, prints out every matrix with a line in between just so it's easy to see. Now, since I did have the matrices randomly generate numbers between -100 and 100, I found that it's very rare that zeros appear in the matrix, and I'm getting these extremely high determinant values because of that. Now, if I had set it to generate numbers randomly between -10 and 10, it would probably have a lot more matrices that actually have a determinant that is zero or very close to zero, because as you can see at the bottom, the amount of randomly generated matrices with a determinant of zero is zero. So that's kind of what I found with writing this program, but I'll show you a few more examples of how this runs just to show you that it is a pretty efficient program. So I do that again. And this time I'm going to do size 5, so 5 by 5 matrix. I'm going to do it 1,000 times. So that's still pretty quick there. I'm not going to scroll all the way up through this because it's obviously a lot, but as you can see, it counts. It has the number of each matrix determined, and there's a lot of them. So it's a pretty efficient program. It can do this pretty quickly, but as for the actual application of a determinant of zero, this isn't super helpful the way I wrote it, because if I had reduced the inclusive amount for the random number generation, it probably would be a lot easier to tell kind of the probability of a randomly generated matrix having a determinant of zero. But that's just kind of the way it ended up being. So hope you enjoyed this video. Hope it wasn't too boring for you, and thank you for watching.